Now we're going to try and illustrate to you the up and down shift to the general format for a sine or cosine wave. So here we have the shift plus c. If it's positive, it's shifted up. If it's negative, it's shifted down. Here's an example of what it looks like with a parabola. Y equals x squared looks like this, but y equals x squared plus 3 is simply shifted up 3 units. So a sine or cosine function handles exactly the same way. So here we have plus 3, which means the whole function will be shifted up 3 units. So how do we graph something like this? So now let's go ahead and practice everything we've learned so far. So we have to deal with the amplitude, the periodicity factor, or the wave number, if we want to call it that, and the shift to left and right, and the shift up and down. All right, so you can see it all at once. So first of all, let's graph the vertical and horizontal axis. So on the vertical axis, we have the y variable. On the horizontal axis, we have the theta variable, the angle variable. So the first thing we want to do is find the upshift. The upshift is 3 units. So from the horizontal axis, we're going to go up 1, 2, 3, and draw a dotted line there, because that will be the center for our sine wave. Next, we look at the amplitude, and we see that the amplitude goes up and down 2 units from this location right here. So if this is 1, 2, 3, that means this is 4, this is 5. So the amplitude will go from 5 to 1, because it'll be 2 units above and 2 units below the center of the sine function. The center of the sine function, again, is defined by the up or down shift, in this case, the upshift of 3. So we know that the sine function is going to oscillate between 1 and 5. Right, next we need to have the shift left, right, where the sine function starts. Now notice this is not in the exact same format as to what we have over there. In order to do this right, we have to write it exactly like this. So if we went to here and said, oh, it shifted pi over 2, we would be wrong. Instead, what we want to do is we want to factor out a 2. We want to factor out the k. So this is equal to 2 times the sine of 2 times pi plus pi over 4. You say, oh, I still have to have the plus 3 there, of course. You say, is this correct? If you're wondering if this is correct, go ahead and multiply this back in. 2 times pi gives me 2 pi, and 2 times pi over 4 gives me pi over 2, because 2 divided by 4 is 1 divided by 2, which gives me this again. So I did the factoring correctly. Now I realize that my shift, my left-right shift, in this case, since it's plus, it's a left shift, is pi over 4. So let's put in the horizontal units. So if this is pi over 4, that would be pi over 2, that would be 3 pi over 4, and this would be pi, and that would be 5 pi over 4, that would be 3 pi over 2, that would be 7 pi over 4, that would be 2 pi, and let's make it, how about 9 pi over 4. All right, to be complete. And on the left side, we have a minus pi over 4. And notice that the shift will be to the left, pi over 4. So the sine function will start right up here. Of course, not down here. We have to go up here. So the sine function will start right there. We know that's going to oscillate like this. Now, since k is equal to 2, remember that the period is equal to 2 pi divided by k, and in this case it'll be 2 pi divided by 2, which is equal to pi. That means we'll have one complete section of the sine wave in a distance of pi starting from minus pi over 4. So from minus pi over 4 to 3 pi over 4, this is a pi section, like that, which will carry a complete wave, so to speak, a complete section of the sine wave. So that means we'll go up, down, down, and up, and we'll be between this line and between this line right here. So that will look like this. Let's see, 1 pi be up, down, down, and back up. So this is what it will look like. Right there, like that. Okay, and in a 2 pi section, so this is pi. If we add another pi to that, 1, 2, 3, 4 right there. So this is another pi like that, pi, so that this whole is now a 2 pi section. Remember, when k is equal to 1, a sine wave will be this long on this graph, but because k is equal to 2, that means that it's only in half the distance, and so we'll have another complete wave like that. So we had 3 pi over 4, and a little bit further out like that. Okay, so I have 1, 2, 3, and 4. So we'll draw the wave again, 2, 3, and 4. So now we see that in a 2 pi section on the horizontal axis, we have 2 complete portions or sections of the sine wave. And this is because k represents the number of sections of sine wave or cosine wave you'll have over a 2 pi section on the horizontal axis. So now we have everything. We have the amplitude, 2 above and 2 below the average position of the sine function. The average position of the sine function is given by the shift up. In this case, it's +3, so it's shifted up from the horizontal axis 3 units. 2 units above and 2 units below for the amplitude. The k means there's 2 complete sections of the sine wave in a 2 pi portion on the horizontal axis. And finally, the shift to the left, plus means to the left. And of course, we have to write it in this format to realize that the shift was pi over 4, not pi over 2, that some of you might have tried to do in this case. Remember, you factor out the k, that leaves you with a pi over 4. The plus means to the left, pi over 4. So this is the shift to the left, and that would be represented by the b right there. In this case, b is equal to pi over 4. All right, and that's how we do that. If you understood what I just did, you're ready to take any function, any sine function, any cosine function, and graph it appropriately based upon the amplitude, and in this case, the k, the shift left, right, and the shift up and down. And that's how we do that.